Hello and welcome. So I've been spending the last 6 months or so creating an app. It's for Android, Linux, and anything else that runs Python basically. It's a free and open source app. It always will be. It's available on GitHub now. The link is below. I hope you enjoy it. Let's have a look. Okay. MIDI Mesh, in its default configuration, behaves essentially like a mesh network and is inherently high entropy and random. But there are a multitude of ways to control everything and make things behave in a predictable manner, which I will describe at least partially throughout this video. There are three main components: nodes, connections, and packets. One of the most powerful tools for taming the chaos of the default mesh network is the grid. Locking nodes to the grid locks packet speed to the MIDI clock, and creating little self-contained local networks creates the perfect conditions for synchronized ARPs, polyrhythms, and other complex sequences. And from there, you can up the complexity to your heart's desire. To ensure this all makes sense to anyone not yet familiar with this kind of workflow, let's go over the three main components in more detail and showcase some of the ways they can be controlled. Standard nodes are created by playing a MIDI note, either with the on-screen keyboard or with an external MIDI controller. The created node contains the note information such as the octave, velocity, and note duration. By default, note velocity also determines the velocity at which a node travels, but node speed can be manually increased or reduced to 0, which immediately opens up a wealth of opportunity for pattern composition. Nodes also contain logic for dealing with packets in a number of different ways, which we'll go into later. When two or more nodes come into a specified range, a connection can be established, allowing nodes to send packets to each other. Connection length helps determine timing in the overall project. And again, by default, the connection process is random. But connections can be locked, blocked, and removed. And a limit can be applied to the maximum amount of connections a node can have at any given time, and the maximum distance at which a connection can be created. A packet can be considered as a playhead. Packets travel along connections and trigger the note information contained within the nodes they visit. The speed of the packet, combined with connection length, determines playback speed.
By default, packets have a set life and speed that can be adjusted by these sliders. Packet speed can be set to very fast, or slowed down to 0, and a packet's life can be set to last for minutes, or it can be set to die instantly. But in essence, the packet life slider is actually a very weak governor. The integral logic for packets is kept within nodes. Out of the box, nodes send and receive packets without interfering with the packet itself. The packet arrives, triggers the note, and then it's free to move on to the next node, or return to the previous node. But by setting the logic here, you can make individual nodes spawn or remove packets if a specific set of conditions are met. I won't go into too much detail. The logic configuration is for you to discover, but I will show you the general logic now and give a couple of examples. So, we have node A, B, and C. When the packet logic in node B is configured as such, and the packet logic in node C is configured as such, then when a packet arrives at node B, it triggers the note, and the packet is free to pass through as usual. However, when it arrives at node C, it is removed from the system. Okay, so that's very simple, and is a pretty self-defeating setup. If we go to node B and set the logic to this, again, the packet will initially pass through to the next node unhindered, but as soon as the node is removed at the next node, it respawns at the previous node. Adding more nodes that are set to remove packets creates a randomized arpeggio machine. So that's one example. There's a myriad of other tweaks and configurations you can do. Have fun with it. There's also a host of mini applications to play around with, such as a 128-step sequencer, a 256-step tracker, both of which can be extended by queuing saved patterns, as well as a bunch of other goodies for you to explore. And I will add more features as time goes by, but for now, upon release, my main focus is improving usability. So I'll leave it there. Thanks for watching. Go grab the APK or clone the repo and run it on your Linux machine. Please let me know what you think. I hope you have a lot of fun with it. Take care. Talk soon. Bye.